Okay, so in this video, we're going to take a look at more examples of linear speed and angular speed. Recall how latitude is the degree measure of the shortest arc from that point to the equator. What that means is if I have, let's say, the Earth here, and here's our equator, given by the starting position of our angular measure, right? We know that, I'm going to go ahead and draw this in a 3D shape as well, so that way you can kind of picture that this is a globe, right? So something like this, okay? So we have a 3D globe here, and it says that a city's latitude is 36 degrees north. So based on our definition of latitude, remember you go from 0 degrees and you go up 36 degrees north. So a location like this will represent 36 degrees north. And we're talking about a city somewhere in the world that's located kind of like in that position there. Okay. How far is it from the North Pole? So here is our North Pole. And what we want to do is figure out how far is it? How far is it? If you think about what that question is asking for, it's looking for a distance. How far is this distance like this? Oh, what is that? That's actually looking for arc length, right? We're looking for arc length there. Okay, so recall how arc length, we can represent that with the letter S. But what we need here is actually, if we're looking for this red piece, we kind of have a wrong angle measure. If you think about it like this, we can form a 90-degree angle there, and therefore the arc length is actually made up of this angle here, which would be the same as 90 minus 36 degrees, right? So that'll give us a measure of 54 degrees there. And so what we know is we're dealing with a 54-degree angle that creates this arc length. And simply put, because all we're looking for is the arc length, we're actually not looking for any speed at all. So there's no need to be using the formulas that we had seen in the previous video. Instead, you really could, with arc length, remember, we can establish a proportion. And that proportion would look like the length compared to the angle. And so the length that we have, the arc length that we are looking for, the part is S, versus the whole. What's an entire circle's circumference, right? How far? Oh, sorry about that. It already told us that the radius of the Earth is 3,963. So we can go ahead and plug that in, that the circumference is going to be 2 pi times 3,963. Okay, so with that in the proportion, we can now go ahead and plug in the angle parts, which are, we know that the part that forms the sector is 54 degrees. And then a total circle's angle is going to be 360 degrees. And so all that's left to find is the S. So we can go ahead and do a little bit of calculations now. Just like that. Again, I'll get my calculator open. Okay, so what we have is 54 divided by 360, and then that value times 2 pi, and multiply that by 3,963. And we get a value of 3,735.0, let's call it 0.04 miles. Okay, so that's all the question is asking for. It only asked for how far is it from the North Pole, and that's what we have found, this arc length here. Okay. Now let's actually look at some speed again. Okay, so number 6, we'll do another example of speed. Earth's rotational speed at a city is the circumference of the circle the city travels divided by 24 hours. What's the Earth's rotational speed in Bangor, Maine? So latitude is 45 degrees north. Again, I'm going to establish that we have a globe. And from the center point, the center of the Earth, here's our globe. From the center of the Earth, we know that we can create an angle measure of 45 degrees north, so that'll look something like this. Okay, here's your 45-degree angle, and this is where Bangor, Maine is. Okay. Now, what we're trying to find is the Earth's rotational speed. So recall from our previous video, if we're looking for the rotational speed, we're seeing that if there's a person somewhere here on Earth, they are traveling along the Earth at some kind of speed, right? They're going around the globe at some speed because the Earth is spinning. So for that reason, what we need is to establish, well, first of all, at that particular point on the Earth, how far is that person from the center of this spinning circle here? Because keep in mind that a person here at this point on Earth is not going at the same speed as a person at this point on the Earth. They're going at different speeds because they're spinning. It takes the same amount of time, but to go as a different amount of distance. So keep that in mind. Okay. So what we need to do is what we can establish here is, given that this is a 45-degree angle, we know that because, again, we can form a perpendicular line, we have another 45-degree angle here. And the reason why we want that 45 is really because we're trying to find out what is the radius of this person on Earth at that location. So we want to find the radius. And with our given triangle, then, we know that we have a 90 degree, a 45 degree, and we're trying to solve for this side R here, okay? So using a little bit of basic trigonometry, things that you've learned before, we know that we can establish that sine of 45 degrees is equal to opposite the radius over the hypotenuse. And the hypotenuse, what is that? Well, we know from the previous problem that the radius of the Earth, it doesn't change, right? We can still use the same information, that the radius of the Earth is 3,963 miles. So this is going to be established as 3,963 miles. And therefore, we have sine 45 is equal to r over 3,963. Okay, solving for r is equal to 3,963 times sine 45. That's the same thing as square root 2 over 2. Okay, and then you can just plug that in, get your value. Let's see what we get there. So 3,963. You know what? I'll just plug in times square root 2 and then divide it by 2. There we go. And we get 2,802.26. Okay, so r is equal to 2,802.26 miles. Keep in mind, that's the radius of that point on the Earth. So if you were to look at it, you know, this person standing here, remember, they're going in a circular motion around the world, and they're going a distance of 2,802, or the radius that we formed, actually, sorry, not the distance, but the radius formed is 2,802.26 miles from the center of the Earth, the axis of the Earth. Okay, but if we really want to find the speed of this person at that point in time, keep in mind we're trying to find out how fast this person is going around the Earth. And so we know that speed given by velocity is equal to how far you go, the arc length, divided by time. Okay, or basically in this case, the speed is equal to the circumference divided by the time. So our v value is equal to the circumference, 2 pi times the radius at that point on the Earth is 2,802.26 miles, divided by how long does it take to go around the Earth? It takes 24 hours. Okay, so v is equal to, let's do the math here. We've got 2 pi times 2,802.26, and we're going to take all that and divide it by 24 hours, and we get a speed of 733.63 miles per hour. That's how fast this person is going at this location on Earth. Okay, and that'll do it for section 1.